Hello everyone. In this lightning presentation, I would like to talk about the opportunity of observing seismic nucleation phases and resolving earthquake rupture directivity using the proposed Rupture and Fault Zone Observatory. I'm Haoran Meng from Scripps, UC San Diego. Earthquake is the sudden failure of earth material and then radiate seismic waves recorded by seismic stations. There could be a preparation process that has been going on for a while before the rupture of the earthquake. The preparation process, also called the nucleation process, includes slow sleep on the fault, as well as other strains or stress perturbations in the source region. The perturbations can initiate a sleep event on the fault of a small asperity and then radiate seismic waves that can be recorded by a near source seismic station. The seismic signal generated by the tiny sleep event preceding the earthquake arrives before the P wave is called precursory signal. Let me show you an example. This is a magnitude 3.9 earthquake in the 2019 Ridgecrest earthquake sequence. There is a precursory signal preceding the P wave about 1.1 seconds with smaller amplitude. We can see by amplifying the precursory signal by about 8.7 times, it's almost identical to the P wave. Not only for one station, we've observed the precursory signal of the magnitude 3.9 earthquake at many stations in a nodal array deployed in the Ridgecrest region by U.S. Geological Survey. The nodal deployment includes many linear arrays across the fault, which is pretty similar to the proposed Rupture and Fault Zone Observatory in Southern California. We can clearly see the precursory signal at stations in different directions. These signals are almost identical to P wave, but with smaller amplitude, and they are preceding P wave with almost the same time. This indicates the corresponding sleep event of the precursory signal is co-located with the magnitude 3.9 earthquake and have almost the same focal mechanism. Therefore, this precursor could be part of the nucleation process of the magnitude 3.9 earthquake by increasing the shear stress of the surrounding area and finally trigger the magnitude 3.9 earthquake. We have observed many earthquakes with such nucleation phases from magnitude 0.9 to magnitude 5.4 in the 2019 Ridgecrest earthquake sequence. The earthquakes with nucleation phases exist in the entire rupture area of the 2019 magnitude 7.1 earthquake and in the entire seismogenic depth. In addition, the preceding times of these nucleation phases seem to cluster within 15 seconds before the following earthquake. The proposed Rupture and Fault Zone Observatory has similar linear arrays across a major fault in Southern California, will provide an excellent opportunity to systematically observe the nucleation phases in this area. This systematic study can potentially benefit our understanding in earthquake physics and make contributions to earthquake early warning and earthquake prediction. In addition, the proposed observatory are also very useful to resolve the rupture directivities of the small and moderate earthquakes in Southern California. By using a smaller co-located earthquake as an empirical Green's function, we can perform the deconvolution to get the apparent source time functions at different linear arrays of the observatory. The stations in the rupture propagation direction will show an apparent source time function with shorter duration and high amplitude, while for the stations in the other direction, we will get longer duration and low amplitude source time function. This is an example of the apparent source time functions at stations in different directions of an target earthquake. we can see the systematic change of the P wave apparent source time function with the azimuth, as well as for the S wave in red. Our previous study of the finite fault attributes of the small earthquakes show a systematic rupture directivity towards the northwest in the trifurcation area of the San Jacinto fault zone. These observations are very useful for the earthquake seismic hazard analysis. The proposed observatory will provide much better data coverage together with the regional seismic network. This combination of seismic networks will allow us to robustly resolve the finite fault attributes of many small and moderate earthquakes in Southern California. To summarize, the proposed observatory is very useful to study the pre-rupture and co-rupture process. I'm gonna stop here and thank you for your attention.